Hi, everybody. We're just going to give it a few minutes and let everybody else join. So just bear with us. Just joined. We are just giving it a few more minutes to allow people to jump on if they've had other commitments right before. We'll get started really shortly. All right. I will kick us off so that we keep everything on time and don't go too far over. So welcome, everybody. Thank you so much for joining. This is the 15th webinar in the UG2 webinar series. This is a webinar I'm particularly excited about. We are going to be focusing on the early career aspect of gliders, and we really hope that with help of our fantastic panel, we can sort of provide some insight and some guidance for those that are early career in this field. Next slide, Cassie. So just quickly, we'll run through the agenda. I will be providing some UG2 updates, and then we will move on to the panel. We have a very fantastic panel with us today. It's comprised both of some more established folks working within academic and industry sectors, as well as a few more early career insights. So I'm very excited. I want to thank the panel as well for joining and taking time out of your schedules to help. Today's panel will be actually moderated by Joe Gradone. Joe is a member of the UG2 steering committee, as well as the head for our early career subfocus group. So thank you again to Joe for volunteering to moderate today's panel. There will also be some time at the end of the panel for audience question and answer. So please think of some questions. You can either write those down in the chat or raise your hand when we open that up for discussion. And we also really want to use this as an opportunity to ask you what you need from us in terms of UG2 as an early career focus group, especially as we have an upcoming workshop. We really want to make sure that we are fulfilling the needs that you have in terms of training or questions or sort of particular aspects that you want us to focus on, for example, resume development or just access to career websites and so on. So please, this is a great opportunity for you to provide that information to us. And then I'll finish up with a quick wrap up of some of the sort of final UG2 business items at the end. Next slide. As always, I just want to highlight that we have a fantastic steering committee for UG2. They work very hard behind the scenes to help us continue to meet the mission of UG2. So as always, a huge thank you to them. They will be particularly busy this year as they're also serving as the organizing committee for the UG2 workshop in September. So again, a huge thank you to them. If you ever have questions or comments, please feel free to reach out to them or myself as well. Next slide. So just some quick UG2 updates from me. Most importantly, next month, we have a UG2 town hall. It's at the OSM meeting in New Orleans. We are having our town hall on the Tuesday. It's over lunch. So for those that are going to OSM, please do come along. Again, we have another great panel, and we'll be looking at the current and future role of glider technology in ecosystem monitoring and marine population management. I feel like this is a great topic to follow on from the town hall we had at MTS in September last year, because we've gone from talking very much about the technology specifically to really looking at what we can do with the data in terms of biology and ecosystem management. So please do come along to that if you are attending OSM. If you're not, don't worry. We'll be sending a report out a few weeks following the event, so you can catch up on everything that was discussed and presented. So there will be a few more reminders as we get closer to OSM. And then I guess the biggest update, I've sort of alluded to it already, we are having a UG2 workshop in September. This will be almost 2 years to the day from the last workshop. We are having it in Ann Arbor, Michigan, from September 10th to 12th. We're very excited. We've got lots of work to do. Thank you to those that filled out the expression of interest. We've been able to sort of start gathering some really good ideas for topics and themes for that workshop. And we've sent out a save the date. The biggest next update will be in April. In April, we will open the call for abstracts as well as registration. I do want to take this opportunity. I feel like it's a great time to do that with an early career panel and webinar. We will be having some travel funds available. We will be putting preference on early career individuals, students, and those from sort of small island developing states. My only advice with that, we will have to set a deadline. So if you are interested in some financial assistance to attend the workshop in September, please do register earlier rather than later. We'd like to help as many people as we can come to that workshop. And then finally, as always, we have some documents available for everybody to access. We have the town hall summary from MTS in September, as well as the workshop report from 2022. So it might be a good time to have a read of that as we move forwards to September for the next workshop. Next slide. Great. So I will pass this now on to Joe, excuse me, who is going to run this portion with the panel. Joe, take it away.
Cool. Thanks, Georgia. And hi, everybody. As Georgia said, I'm Joe Gradone. I'm a PhD candidate here at Rutgers in the Department of Marine and Coastal Sciences, and I'm also on the steering committee here at UG2. And I'm really pleased to be helping to lead the development of this new kind of early career sub-focus group. So to kick the group off, we have today's early career panel. And without further ado, I'll kind of just jump into my duty as the Vanna White for the panel today and get into our introductions of all the panelists. So first up, we have Catherine Edwards, who is a physical oceanographer at Skidaway Institute of Oceanography and the University of Georgia. Her numerous programs focus on investigating coastal oceanography and management with autonomous underwater vehicles, as well as optimizing their use with engineering principles and real-time data streams. So I think we'll just go kind of one by one, and after each intro, I'll let the panelists talk about themselves for a bit here.
Okay, Joe, thanks so much for the introduction. In thinking about what message I wanted to kind of give for early career scientists and how to, I guess, talk about some of my experience and where things are going. I got into gliders as an early career scientist. And so I think early career has fundamentally guided my journey with gliders. I was handed a glider my first summer of graduate school in 2004. Unit 32, a G1. There were no manuals at the time. Just lots of generous colleagues, Liz Creed and Matt Palanza, who is at Teledyne or at Webb Research, Clayton, and then Ben. And as I kind of grew as a scientist and as a glider user and operator and looking into the engineering of the gliders, in terms of their use, I was largely kind of operating as a one-woman shop until fairly recently, about 5 years ago. So I hope that perspective that's what shapes my perspective in giving some of the guidance and notes. My current lab members got into gliders through a wide variety of ways, some of them looking for undergrad research opportunities. Some of them met at a public lecture who were like, this is cool, how can I do it? One who came on a lab tour from Savannah State University, and then a lot of people through referrals and through the networks that we have. And just sort of keeping in touch and saying, hey, let's find a way to work together. And we did. So in terms of advice, my number one piece of advice is to work on your technical and troubleshooting skills. The troubleshooting skills are so important. To be able to troubleshoot what's going on with the glider, you have to really understand how or if a glider thinks, why the glider is doing what it's doing, and then think about it from just like you're debugging code. What is the expected result? And then what are the ways to break that result, right? And so then going back through, if you understand how the glider thinks and moves, then you can go back and really help with your debugging. That allows some good bit of relying on yourself to figure things out as you go. There's a lot of times, especially in the field, where you have to rely on your own judgment, trusting yourself. And sometimes there's a lot of hard calls. You might have to push back against a senior colleague. You might have to push back against a boat captain who really wants to get home, but you're not ready to leave the glider yet. And so it's a process in the early career to develop that judgment and trust yourself. I used to spend all my time skydiving, and there's a saying in aviation that's, how do you get good judgment? It's through experience. Well, how do you get experience? It's through bad judgment, and I'd add a little bit of luck as well. And so I think that applies pretty nicely to gliders and anything operational and high risk like this. That situational awareness is really important. You're constantly doing risk assessment. You want to learn from your experience and from the experience of others. Understanding when a little luck has helped you, and then how to avoid things next time. And then lastly, the importance of your training and using it. Skydivers practice their emergency procedures every jump and between jumps and work on things on safety day. I do the same thing in the lab. Every time a glider goes in water, I confirm that it is, sealed, that it has a vacuum and that it's on, and that it's, so that's the thing I repeat to myself anytime I put a glider in water. So these are some of those skills that have helped me, I think. As a scientist, however, in academia, it's important to remember that the science drives the operations. Overwhelming can be really overwhelming. Just getting the thing working is fine. But operations don't get you tenure. They don't get you a dissertation. They don't give you publications. They don't necessarily reward some of the traditional academic tracks. And so making sure that the operations serve the science is foremost. And some of those balances are different. There's lots of roles in academia for gliders, a glider technician or faculty or student or pilot. So some of those balances are different for the science and the operations, but I think successful people at all of those levels have understanding of both the science and the operations. And then lastly, your community is your network, is everything. More and more academia is moving toward more integrative work. And as the technology gets more advanced, it gets harder and harder to do it as a one-person shop. But I think it would be less common to be able to, I think it's becoming harder and harder to spin things up by yourself. So I see people moving towards operations clusters and partnerships. You don't have to have all of the skills, all of the people in your lab group to do what you need. But if you know the people who can do this, then you can put your superpowers together on and to grow programs. I think we're seeing more things in terms of fleet. So let me back up and say, my science is a combination of the science, the oceanography, and the engineering, how to optimize the sampling to get the best scientific results. And in the oceanography world, some of the stuff that we do is in the oceanography world, it would be, sorry, there's a pop-up. There are things that we do through joint engineering oceanography partnerships that are considered transformational in oceanography in terms of how we can get better data, but they are considered so boring to the engineering world, to the academic engineers. And I think that's a space that we can continue to grow and use some research in engineering for other autonomous platforms, cars, vacuums, things like that, to be able to take some of the burden off of humans and make sure that the science is of the highest quality and can answer the questions that we're going after. I think we also want to make sure we can demonstrate and quantify our impact. That's becoming more and more important in real-time applications. And I guess my last little with an IU's hat on, I'll say that data management falls behind our cutting-edge ability to put instruments on to our gliders and to be able to share our data and use it in real time. I think this is the community in which we can think about how we use our data, what are the standards, and what are the ways that we ensure it's of the highest quality. Thank you.
Awesome. Thank you, Catherine. Your perspective's just really awesome. Okay, so next up we have Shea Quinn. Shea is the product line manager of the Slocum glider at Teledyne Webb Research, and he is responsible for driving the product line development for gliders and bringing the voice of customers to the engineering and development process. Shea joined Teledyne Webb Research from Lockheed Martin, where he held several positions within the engineering group, including most recently engineering project manager. So I'll hand it over to Shea.
Hi, everyone. My name is Shea Quinn. As Joe mentioned, I am the product line manager for the Slocum glider here at Teledyne Webb Research. I kind of come to the glider community through a non-traditional route compared to, I think, a lot of folks that are now using gliders. I have an engineering background, but I did spend most of my career working with subsea vehicles, ROVs, and gliders. I've been with Teledyne for 3 years now, and I've been able to my experience in designing and operating other kinds of underwater vehicles to apply that towards gliders. I think that because of my sort of non-traditional glider background, I think a lot of glider users or those in the glider community come from science. They come from oceanography or physics or biology or some other kind of related field to how gliders are used to gather data, how gliders to explore the oceans and map how things work and all that. Whereas I sort of come from the background of just how do we make the glider work, or how do we make a vehicle work? So for me, I think that my advice towards early career individuals is that there is a lot of different ways that you can get into gliders. There are a lot of different routes, and there's a lot of different jobs, as Catherine mentioned, that have to do with gliders. There are scientists, there are engineers, there are technicians, there are operators and pilots. There's a lot of different ways that people can become involved with the glider community. I think the fact is that all of those different jobs are interconnected with each other. Like I said, I'm from the engineering background, but now a big part of my job is understanding the scientific side of stuff. In my role, I really strive to work with our customers to understand what their needs are, what their missions are, how they plan to use a glider during deployments, and then make sure that we can deliver them a vehicle that has the sensors and the hardware and the capability to serve that mission. So it's all interconnected. But I guess my point is essentially that despite coming from the let's just make a vehicle work underwater kind of background, you have to be able to understand the other aspects of the job, the other aspects of a deployment, the other aspects about how it all works, even from an operational standpoint with working with boat captains and working with, within the structure of either a company or a university to make it all work. So despite the fact that there's a lot of different backgrounds and you might be focused in one area, it's good to sort of dip your toes in the other pools to make sure you kind of understand what everyone else is doing on the team. Because that's sort of my other experience with subsea vehicles and with gliders is it's very much a team effort. And everyone may have their own assigned role. The more people can help each other with the use of gliders and the missions and looking at data and troubleshooting problems and the rest, the more valuable it becomes as a whole. So, like I said, from my perspective, again, I kind of come from the technical background, but now I'm learning more about the scientific, different fields of science, much more about fields of oceanography than I thought I'd ever known. I'm loving that part of it. And the role that I'm in now allows me to do that. There's a lot of my job is focused working with Cordie's team, who does the glider support and training. I work a lot with our engineering team to, understand what new technologies we are able to make for gliders, or what the next sort of technologies that we'll be investing in terms of understanding what the glider community wants or their needs, and trying to focus engineering efforts in delivering, those new capabilities, those new sensor integrations, those new ways to improve the glider product as a whole. And then there's, just sort of the interaction. My favorite part of the job that I have is just interacting with the glider community, being in the field, doing field work, being at trainings, learning about people and the rest. So it's really spans across quite a few different things. And I think that's what I've learned most, and sort of the advice I have to give towards career again. If you're the tool that you can, there's a lot of aspects of this job. There's a lot of different aspects of working with gliders, and the more that you are able to, I'm sorry. Okay. The more that you're able to grow your personal toolkit, I guess, in terms of what you're able to add to a team, the more valuable you'll become. Sort of all I have for right now.
Awesome. Thanks, Shea. We're definitely happy to have you on the glider side of the AUV field. So next up we have Adeniyi Adenaya, who is a glider engineer at the National Oceanography Center in Southampton. He has a bachelor's degree in electrical engineering from the University of Portsmouth, with experience in underwater glider operations, analog and digital electronics, and software development. He provides operational and engineering support to the Mars glider fleet, which includes Teledyne Webb Research Slocums, Kongsberg Sea Gliders, and Liquid Robotics Wave Gliders. So I'll hand it over to Adeniyi now.
Thank you very much, Joe. So as Joe mentioned, my name is Adeniyi. I'm a glide engineer at the National Oceanographic Center. I'm just going to briefly talk to you about how I got into gliders and what my day-to-day is like. Next slide, please. Okay, my professional background is in electronic engineering. In my previous job, I was an electronic test technician. My main job was to test AC to DC converters, DC to DC power supplies, and to make sure that they're working properly to specification. In addition to that, when a customer sends their faulty units, my job was to find out what is wrong with it, and if it was economical to fix it, fix it. If it wasn't economical, just tell them, sorry, mate, you need to buy a new one. So on one fateful Tuesday afternoon, there was a nice juicy round of redundancies. So I had some, it was nice. So because the company was closing, so I was in between good jobs. So when I saw glide engineer job online, I quickly Googled, what is a glider? I read what it was, I read what it did, and I said, yeah, I can do that. It seems straightforward. And I've been doing that for about 5 years, coming to 6 now. I provide operational and engineering support to our glider fleet. Next slide, please. Thank you. My day-to-day comprises of glider refurb. So I prepare the gliders, make sure that they're mission ready. And then once they've completed the mission, comes back, get it ready for the next mission. Then I ballast it. So we add or remove weights in the glider to adjust the glider's density and to match the density of the water it would operate in. Then I deploy and recover. So after preparing the glider, after ballasting it, it's a bit pointless for the glider to just sit there gathering dust. So we take it to where it needs to go and then put it in the water. And then once it finishes, we take it out. And then we pilot remotely. So once the glider has been deployed, we tell it what to do, where to go, and so on. In addition to doing all that I've just mentioned, I also do some electronic integrations. So some of the electronic tasks that I've worked on, I designed some communication and power supply that helped us to be able to calibrate the Slocum and Sea Gliders CTD in-house. In addition to that, I also worked on the Slocum backseat driver integration. So the Slocum, as we probably know, has 2 computers. So the nav, the science, and then the backseat driver is a 3rd computer. So my job was to provide power to that computer and also find a way of those 2 computers to communicate. In addition to that, I also, when the opportunity arises, I also do some training to just pass on some of my knowledge. Next slide, please. So what I like about the job, I like that every day, every season is different. So I get to work on a lot of different projects. Also, I like traveling. When I first started the job, my colleagues and the people around me, they were listing all the places that they've been. So they've been to South Africa, they've been to America, they've been to here, they've been to there. All I could say was, wow, very interesting, because I couldn't contribute to the conversation. But at least now I can say I've also been to some of those places. So some of those places that I would not even go if it wasn't due to the glider. The bits that I don't like is on the rare occasions where the missions goes wrong. Advice I'll give someone starting out will be, number 1, have a willingness and desire to learn, because there's a lot of opportunities out there. You just have to open your eyes and then grab it, because it's there. And then secondly, get your sea legs quickly, or get a good motion sickness tablet, because the sea will not hesitate to slap you around a little bit. So thank you very much for listening.
Awesome. Thanks, Adeniyi. I think we could all agree that's definitely not fun when things go wrong or seasick. Okay, so up last but certainly not least is Cordie Goodrich. Cordie is the Slocum Glider Technical Support and Field Operations Manager at Teledyne Webb Research. Cordie leads the glider support team, providing customer training, testing new hardware and software, piloting and supporting Slocum glider users all around the world. Prior to joining TWR in 2020, Cordie worked at the Bermuda Institute of Ocean Sciences, where she managed the Mid-Atlantic Glider Initiative and Collaboration Lab. And she received her bachelor's in mathematics from Washington College and a master's in marine science from the University of Delaware. And I'll leave it to you, Cordie.
Thank you, Joe. I'm going to just try to share my screen quickly. Oh, sorry. We're having some internet challenges in New England at this moment. All right, never mind. Okay, so hi, I'm Cordie. Thank you so much for letting me come on and talk. So my background is pretty traditional through sort of the academic route. So I got into gliders similar to Catherine in grad school. So I was a math major. When I was a senior in college, I did not know that I wanted to work in oceanography or with gliders. I kind of found out about gliders through an internship that I did in college at University of Delaware College of Earth, Ocean, Environment. And it was not related to gliders, but sort of being there, I got to meet Matt Oliver, who I ended up doing my master's with at University of Delaware. So I came into this really great lab, and they were working with gliders, and that's how I sort of first got my introduction to gliders. So sort of a pretty traditional, I would say, for many people in the field, sort of through academia, through research. So I did my master's at University of Delaware. I worked with glider data. I got hands-on glider time. I then went on and I worked at UC Davis for a couple of years. I did more glider work. I flew gliders in Lake Tahoe. I did some Antarctic work, flew gliders under the ice, which was really fun and exciting. Following that, I went to the Bermuda Institute of Ocean Sciences, and I managed the glider lab there for Ruth Curry, which was an amazing experience. After a couple of years of that, I sort of switched to the industry side and research for about 3 years. So we, Shea and I kind of have the industry perspective from this, and gliders is what we do. So whereas when I was on the academic and research side, gliders was part of what we do, and the end goal was the science. And now it's more focused of like gliders every day. This is what we do. So my day-to-day always involves gliders to sort of some respect. It varies a lot, and that's something that I'll sort of tie this in with the next question of what do you like about your job? I love the variety in my job. So I'm in the field often. I travel a lot. I travel to be with customers. I travel to do deployments, to do trainings. So my I spend about a week a month away, I would say, which is great for me in my current stage of life. So I go in the field, I deploy, I recover. I'm testing software, I'm testing hardware. We're testing new vehicles. But I also have a lot of time that I spend, on my computer looking at data, digging into things, managing projects. So I quite like the variety sort of that I have in my role right now. It's a really positive aspect for me. I would say that sort of the what do I like again in the industry position at this point, and the pace of work is something that I really enjoy, but also at the same time. So on my experience is much faster. And I love that. I feel like with so much done, pressure is really on, can be sort of hard to deal with sometimes. We're a publicly traded company, so we have goals that we are expected to meet. I think any job you have expected goals to meet, and so you kind of have to just pick your poison there. But I love the pace of the work. Like I said, we get our hands on a lot of stuff. We get to go through and work on lots of really cool projects. But again, it's not for everyone, right? The pace of work is quite quick here. So we really enjoy it, but it's not for everyone. My favorite thing about my job is working with the glider community. I think I've said it sort of for years, the glider community is just really awesome. So getting to work with our customers, sort of helping them make the instrumentation work better for them, is something that we really enjoy. I said before, like the variety getting to do a lot of sort of both in the field stuff and data stuff is really appealing to me as well, in my position. Advice that I would give early career individuals looking to work with gliders. This has been said by some others already, but get hands-on experience where you can. Any kind of hands-on experience that you can get, whether it's in the lab, whether it's in the field, that's going to be really valuable for you, even if you don't think it's something sort of really important at the time. If you have that hands-on experience to lean on, you're really bolstering your resume and your knowledge base. I'm a big proponent of having sort of some at least basic math understanding and some computer science skills. This is really going to bolster your problem solving skills, which Catherine pointed to as well. The problem solving skills in this industry are so important. It's something that you use every day. And, sometimes we think, well, everyone can do problem solving, but no, some people are really good at problem solving, and those people are the more successful people, the more successful candidates going into jobs. So even if it's not your area of expertise, if you can start to sort of tease out the problem solving steps, then this is a really sort of important thing that can make you very successful. I would also sort of say, Catherine touched on this as well, and I couldn't agree more, that sort of believing in yourself and your intuition is really important. You can have sort of this imposter syndrome feeling going in as an early career individual, and sort of believing in yourself, taking the time to make sure you're sort of set up well and you have the knowledge to lean on is important as well, but sort of trusting yourself that you can make good decisions and that you can do it is going to take you a long way.
That's what you got, Cordie, right? Not New England internet stopping you.
You're good. I'm done.
Okay.
Sorry.
Cool. Thank you. Thanks to everybody. That was really awesome. I think we can open it up to, just a general Q&A now. Feel free to just unmute yourself, anybody, and ask a question, or like I said, drop it in the chat and I can read it if you'd prefer to go that way as well.
I can kick us off, Joe. I have a question. So firstly, again, thank you so much. I think something that's, for me, the biggest takeaway from this is how diverse gliders is as a field and how many different routes you can go, how many different sectors, and also that you can go between them too. You're not sort of constricted to one, and actually understanding industry really helps with the science, and understanding science helps operations and so on. So thank you. Do you have any recommendations for great resources in terms of job listings or postings that you can share? I'm not sure if Teledyne has their own website that they list everything, but if anyone has any great links or resources to share, that would be fantastic.
Yes, I can confirm that Teledyne has our own website where we post job listings. Right now I know that there is needs for engineering. We also tend to look for people for Cordie's group and glider support from time to time. We see the field of gliders growing quite a bit, and are trying to appropriately scale on our end as well, while also there's also sort of just a turnover within industry of, you know, a lot of people coming to retirement age, and we need to backfill the science to make sure that we can, you know, continue on the path that we sort of have ahead of us. So I am always happy to take a resume and see if there's a fitting position within our group that works for that. But I know that there's also quite a few other great resources within the glider community, within UG2 even, for finding glider opportunities as well. But if there are folks, especially backgrounds or looking to if they're in the industry side of stuff, we're always happy to, you know, take a look at resumes and see if there's a good fit for our team.
And we can drop our emails in the chat, or we can share them if people want to reach out.
I have a question, Joe.
Okay, go ahead, Ben.
So one of the things I've really enjoyed throughout my glider career is maybe those moments like between the jobs where people sort of let loose and tell their war stories. And I guess I'm wondering from any of the early career people here, if you had like a distinct moment where you realized you really loved this work and that this was for you.
Adeniyi, I think you should go first. It looks like you have one.
I'm actually just thinking. I think the first day or the first time I actually went to deploy it, so it was quite interesting, and getting to meet a lot of nice people and actually being on the sea. It was a different experience, and I said, this job I can actually do. Yeah. And also when I saw my first payslip.
For me, I guess thinking about the some of the first times I felt like, okay, maybe I can do this, is those times when you're like, something something's wrong, but no one can figure it out, and you just keep on working on it in the back of your head, and you keep on finding it. But that said, the moments that I'm like, yes, I got it, are the times when stuff blows up in 100 ways. And it blows up in 100 ways, and it's super high pressure, and you say, okay, this is what we need to do. And you know, whether it's a component failure and knowing who to call, or a component failure and knowing what to do, or knowing that is complaining and you can or you do or don't have to pay attention to all of the dribble that the glider gives you on it. But also things, most recently, we had a glider fail checkout right as we were loading it, like 6 p.m. the day before Frank, the student in the lab, was fixing to drive it down for deployment, for a right whales deployment. And so we troubleshot it and ended up having to, reinstall the operating, found it was a persister error, reinstalled the operating system on the science bay, rated a card from something else, ran a simulation, resealed the glider, pulled it all up, and like, boom. And so that felt like the biggest win. I know it was probably both rewarding and hard for Frank to wake up the next morning and drive with it. But those are the moments where you're like, no, we've got this. We can take care of it.
This is a story for me, though Cordie is involved with it as well. This past March, I guess it was, Teledyne had a demonstration that we did with the United States Navy, where it's a project to drop a glider out of the back of a helicopter in the Persian Gulf. And it was one of those, it was basically, we were told in November that they wanted to do this in February. And it was kind of a quick project in terms of the engineering side of it. Get to put it in the back of a helicopter, then drop it out of the back of a helicopter. It was really a fast-paced environment. We were working with the engineering team and working with the Navy and the rest. And then I was the only person available to actually go to Bahrain, where this operation was happening, and so it was a new environment, someplace I'd never been before, and kind of going in there with a bit of a handicap in that the base we were operating off of, we couldn't use their Wi-Fi. So makes it pretty hard to pilot when you don't have an internet connection to what you're trying to connect to. So it ended up having to be where I'm on a satellite phone with Cordie, who's here in North Falmouth, actually piloting the glider on the other side of the world while I'm there loading it into a helicopter and doing free wave checkouts locally, and then turning it over to Iridium so that she could pilot it for the actual deployment itself. It was a lot of coordination. It was very fast paced, but in the end, it actually worked, and we were pretty proud of that. And it was just kind of one of those that it was nonstop for about 3 months there. And then it was a quick 24-hour deployment, and it ended up working, but not without jumping through about 15 different hoops first.
Yeah, I think like all of these stories really highlight sort of this idea that this field is really challenging, and sort of the people that are drawn to this field are really drawn to a challenge. And although it's challenging, it's absolutely so rewarding when it all works out. Like, it is the most rewarding thing in the world. I can think of a number of examples, like the helicopter was a really fun test. One of my favorite things is, in some of the non-commercial work that we do, we get these asks of, can you make a glider do this? And, when we started getting those questions, and I started to be able to fire off the answers of, oh yeah, absolutely, we can make it do this and this and this and this. Like, that's my favorite game to play, of just absolutely, I can do this, I can make that happen. Give me all the weird stuff. And this is a puzzle I'm going to solve, and it's going to be so rewarding at the end. It's such challenging work, and it will break you down until it works. And then it's absolutely, totally worth it.
I think problem solving is the key thread here. Everybody's once we overcome the problem, then we're yeah, cool, this is awesome. Thanks, guys.
Absolutely.
Maybe we'll pass it off to Sean now. I think you've had your hand up for a bit.
Yes, thank you. So I'm a PhD student in oceanography, and I'm working with gliders, sometimes in the lab. I try and get in there more. Thanks for the advice on that. We have other people on the team that do a lot more of that, and I do more of the data analysis. The question is, as a student, maybe later, a little later, or now in my PhD career, what is a good way as a student to get plugged in with industry? Is there any real connection there, or is it does that usually happen after graduation? Any advice on connecting, plugging in with industry, glider or AUV related, sometime in this later part of my PhD career?
In the interview, I would say that and companies like us are always interested in people who come to us with experience using our equipment, using our vehicles. If it's a sensor manufacturer, using the sensors that they're doing. I think that an easy way a lot of people transition from academia into the industry is saying, hey, I wrote my paper using your sensor. I wrote my paper using your vehicle, or I did this research using your equipment. And then that's something that sort of stands out to us in terms of, especially on a resume, where it's being able to see that it's someone who's interested in joining an industry that they already have experience using the equipment. I think Cordie is actually a pretty good example of this, is that she joined us after being a glider user, it was valuable to us because she came in with quite a bit of glider experience and also experience of being one of our customers. So now that she has sort of both sides of that coin there, having been a customer, now working with our customers, it's something that's valuable for our team, because she can say, I remember when I was a customer and my experience was this. How do we make that part better? How do we make, you know, continue doing this thing that I liked and stuff like that. But for, you know, in terms of trying to make that sort of transition, you know, reaching out to the companies that you've especially or equipment similar to theirs, I think is a good way to kind of get your foot in the door, saying, you know, area of my research, it really depended on this hardware or this sensor or this vehicle, and saying, you know, I can, you know, trying to reach out to the right connection points within that group. You know, I think a lot of industry is interested in getting people involved who've actually used it and have valuable feedback on how it can be used best to serve the academic community.
Awesome. Thank you for that feedback. Appreciate it.
Got a question in the chat. So what types of ocean parameters do you see as a upcoming need that are not currently being collected via gliders? Also, when issues happen during deployments, do you find they mostly stem from the glider itself or the auxiliary optional sensors?
I can take a stab at this one, or at least one thought about it. Gliders have, you know, you can put all kinds of sensors on a glider, and, you know, I think there's going to be, with increasing focus on climate, what climate parameters can we better capture in our gliders, and how to create longer time series and repeat times, all of these things that help create a strong data set. As you put more sensors on, the data management aspect doesn't go away, becomes even more important. And then the standardization, developing community standards about, like, what is, like, how do you calibrate? How do you, like, intercalibration stuff? What are references? What's the acceptable level of accuracy? Those are all problems that are hard for a community to address when you're looking at it piecemeal, when you've got, for example, you know, one group or two groups doing this. And so I think there are some ocean parameters. I think expanding parameters like pH, or looking at how to incorporate some of the newer autonomous systems that involve eDNA and some of the other buzzy things that are going through. You know, gliders don't take samples except for a couple of special models that move seawater on the inside, which is super sketchy. But I think thinking about gliders as platforms for those types of measurements, how can you transition them? But you have to then, you know, that's not just a one or two off kind of a thing. You need a community of practice, and you need to come together as the community so that then something happens with those data. You know, look at our temperature and salinity, and how long it's taken for temperature and salinity to become operational, not just for scientists, but for the Navy and for NOAA, and what it took to get the data back through the glider DAC and incorporate it into NOAA and Navy models. How do you do that for oxygen? Like, let's just go, like, oxygen is fairly standard, or ecopucks, or any of these things that we've used regularly scientifically. Developing those best practice, but also operational use is I think a big challenge, as well as developing the new shiny toys.
I'll sort of spin off of that and say that I think from the industry side of things, the point you made about data, Catherine, I think that's really good. You know, for the last, whatever, 15, 20 years. We've been like working to get these things up and running. And now as groups like UG2 are going to form sort of a standard for these things, then the industry in return, I expect, will sort of say, okay, here we can help making a more polished data set coming out of the glider once these standards are sort of set. So it's cool to see sort of the UG2 group facilitating that, and it'll really help the relationship between academia and research sort of move the product line forward to what the community needs.
Catherine, I see there's a follow-up question for one of your statements in the chat there, if you want to respond to that.
Sure, I can do that. I saw Adeniyi had unmuted, so I wanted to give him the opportunity.
Yes, I wanted to add, part of that question towards the latter part where the question said, do issues happen from the glider or the sensor? It could also be, let's say the glider is fine, the sensors are fine. It could also be like the environment. So I'll tell you a story. There was once we were recovering a glider. The water was very fast, was about 3 knots plus. And then the glider decided to pop up in like a shipping lane. So we saw the ship coming, fast approaching, it knocked it. And then we were now rushing to go and collect the glider because we're like, before another one comes and hit it. And then we also hit the glider. So, so environments like that can also cause issues to make the glider not work in a sense. I hope I answered the question.
And for Jackie's question about letting science drive the operations and advice for early career researchers using gliders, I think if you're working with gliders now, stay tight with your group, stay tight with the industry, leverage some of those resources. It is really, really, really hard to spin up glider operations on your own. There is so much to do with so much to do. So I think there's some care to take in terms of how much you want to take on, particularly as, as a tenure track scientist. Do you want your mark to be in the gliders and the co-related development of the ocean science and the glider science, or are there ways that you can take set some of the operational burden aside and participate and support as you can focus more on the science, on a science question that you can perhaps more easily translate into what rewards your career, whether it's for tenure or promotion or for things like, papers that you get out and stuff. Consider what your goals are in terms of the metrics of how what qualifies as success in your world, fair or not, right? Interesting or not. I love all the operation stuff, which is why I'm like, don't spend all your time on the operation stuff. You'll drown. In terms of how to push the boundaries of what science gliders are capable of supporting, I think there's lots of ways people do that. And the trick is finding the flavor that makes sense for you. The work I've done with gliders now for over 20 years it's been in the Southeast Atlantic, where tidal currents are super strong, and we've got the Gulf Stream. Our first Gulf Stream mission was 2006, I think. That drove the scientific questions for the engineering development that we've done. So it's actually the science that drives. It's the scientific questions. It's applied in some measure in that you have to be able to take measurements in a Gulf Stream. How are you going to get the best thing? But also, how are you going to put together, for example, how are you going to assess density gradients to see if you've got a geostrophic relation. And so that goes into how you plan your work, and also sets you up for how you answer your questions. Other people are really driven by sensor development and what that one new sensor can do. Others are in novel ways to use the sensor information, combining, for a good example, combining acoustics with modeling to be able to better interpret the signal that the glider is getting through either passive or active acoustics. So I think that can be a kind of a personal challenge in figuring out where's your crack that that where you can kind of push the science forward. I don't know if others have other takes on that.
Sort of from the industry side, I would also like to add that we are always willing to have a conversation about, can a glider be used for this? We are always looking to our customers in the glider community to kind of give us direction in a way of what technologies need to be developed next. Where glider use is going, which kind of sensors or data gathering capabilities are needed, and then what other sort of capabilities would be helpful or needed to address certain missions or deployments or any other kind of work that needs to be done. And this is one of my favorite parts of the job, is when people come to me and they say, hey, I'm not sure if a glider's ever been used in this way before, but can we add this capability? Would this kind of sensor work on this glider or not? And sometimes the answer is, no, I don't think so. I think, or it would take a lot of work to make it, or there's a different platform that's probably a different AUV or something that would be better for that type of work. But often the answer is yes, let's think about how we could make that happen. And one thing that I like about working for this company, at least, is that we really are very often willing to kind of take on what we like to call like science experiments or engineering specials, which is, let's try integrating a sensor we haven't done before. Let's try integrating a capability that hasn't been done before. Like Cordie said, when she gets thrown sort of, puzzles to solve by certain customers, how we can make gliders do that. And so if there is ever that question of, can gliders be used to do this kind of science, come to us. Or if you're saying, I want to do this kind of science, can gliders help me do that? Then we are always willing to have that conversation.
Awesome. Thanks, guys. Any other questions out there? I have one for y'all. I was wondering what you view as kind of the biggest learning curve associated with working with gliders, whether it's, physically gliders, hands-on, or coding with gliders, or even the other aspect of working with gliders and coding glider data. And what are the ways you've kind of overcome that?
Maybe I can start by saying, I can say sort of like what my biggest learning curve was, but I think one of the really cool things about the glider field is that, and I always say this, like the scope is so broad, right? Like there's like computer science, there's electrical engineering, there's mechanical engineering, there's oceanography, et cetera, et cetera. So depending on sort of yeah, that's what's to be probably good in the learning and then that
Might have lost you, Cordie, if you can hear us. Maybe turn off your camera. See if that helps a little bit.
one of the cool things is that oops, is that that there is such like a broad scope for gliders, and you really sort of get a feel for the different perspectives. But for me, it was definitely sort of the electrical side of things, and it's still something that I work to sort of understand better. One of the things that I really liked about coming to work at Teledyne Webb Research is, I was working in a lab, prior with a couple people before starting this job, and we would have a problem and we'd be like, man, this is a hard problem to solve. I wish I had these resources. We'd reach out and we would get the answers. But here, like, there's a whole team of electrical engineers here, and there's a whole team of mechanical engineers and software engineers. So I think a cool aspect about our job is that we have access to these really intelligent people that know sort of very specific stuff about electrical engineering. So, for example, that's been really useful for me to sort of continue to overcome that learning curve.
Yeah, so just to repeat my question, it was so I was asking about kind of the biggest learning curves associated with gliders and ways you've overcome them. Whether that's working with them, physically, or the glider data, or all the multiple aspects of gliders.
I'll jump in. I think for me, again, I kind of came from the engineering side, the technical background. So a lot of my previous work was done in just building engineering systems, managing engineering projects, that kind of stuff. So for me, still, it's really the data analysis and looking at the data and really making sense of what the glider is spitting out from various sensors and putting that together into like a useful sort of overall look at what's going on in the ocean. It's not a big part of what I do in my job. I'm not usually the one who's looking at data and putting that together. But it is the side of stuff, again, where as someone like Cordie, who's done a lot with computer science and has done a lot of work with oceanography in the past, has a lot of experience putting that all together. For me, it's like I was an electrical engineer. I don't struggle with the electrical stuff like Cordie does. But as soon as there's a bunch of data in a huge file that needs to be put together into an image that shows actually what's happening with, salinity over an area, that's where I'm like, I don't know how to do all this stuff. So I think, like she said, it depends on your background. It's important to learn how to, how different aspects of glider use work together. But I think there will always be strengths and weaknesses when it comes to kind of that learning curve at the beginning.
Maybe one more comment, and I say this to everyone that I am bringing into my group. I say, you have to be willing to come to work every day and learn. So I think sort of the getting over it part is saying, I'm going to show up, but I'm going to be ready to learn something new every day, because there's a lot of information there. There's a lot of sort of nooks and crannies that you can specialize in with respect to glidering in general. So I think this idea of being willing to show up and learn something new and sort of maybe push your ego aside for a moment, and just show up to work and learn every day is super important.
So for me, I think the biggest learning curve, and this might be a little specific, but I think it applies more generally, is interpreting the glider's flight. And so, you've got this little periscope of what comes back from the glider. And even if you send large amounts of data back, ultimately, you can end yourself. We have strong currents, we have tidal currents. So currents are changing over time scales. Currents can change rapidly over a 4-hour surfacing interval. And gliders can move a lot more slowly in shallower water versus deeper water. And so it can be really difficult sometimes to assess how much progress am I making? Am I flying like a bread truck? Yeah. Are there currents moving against me? Partly because the water velocities come back based on your progress, based on dead reckoning. So a lot of the variables in terms of glider flight are tied into each other. So one thing that helped me in terms of understanding that a bit more is thinking more about the algorithms that are underneath it and finding the little bitty text file, the how-to flight, that's buried like 8 layers into the doco folders for the Teledyne documentation stuff that goes into the algorithm that's used for averaging flight during inflections and things like that. And thinking about the dead reckoning and then taking it back. So I guess to generalize it, it's taking the deep dives to understand the parts that are kind of got missing pieces. And I think that's helped me put together something a little bit better understanding where that stuff is, I think for me, a very difficult thing to understand from the instruments as they're flying in, especially in complicated places.
And for me, the main challenge that I went through was because I work with multiple systems like the Slocums and sea gliders. They all do similar things but different ways. So I had to kind of twist my mind. So okay, I'm working on sea gliders. Twist my mind to sea gliders. And then one thing that I really remember, I tried my best to remember, is not really the information, it's where to find information. So if I want to do something with Slocum and I can't quite remember it, I'm like, okay, this is where I need to go to find information about Slocums. This is where I need to go to find information about sea gliders. This is the information I need to go to find information about the wave gliders and so on.
Awesome. Well, thank you guys all so much. I think for the sake of time, maybe we'll jump into our kind of last part here, which is just getting some feedback from you all on the direction of where we're going to head with this early career sub-focus group. So maybe, I don't know if we can do this, Cassie, if I can maybe share my slides and you can launch the poll. Perfect. So Cassie's launched a poll, and I'm going to test the limits of our technology here, and hopefully you guys can see my slide there as well. And I just have like a few quick notes on the early career sub-focus group that you can listen to while you fill out this poll on the direction of where we're gonna kind of go, and keep in mind that where we're seeing this group going is providing opportunities for early career glider users to further advance their careers through capacity development, training, and networking opportunities. And a few, I guess months ago now, we sent out a survey, and just to quickly kind of summarize it, here's a few of the survey category results. I want to highlight that we just achieved one of the things that folks were really interested in doing, but the other ones that received interest were, kind of broadly training, networking, and then this idea of like a mock proposal building session from established PIs, whether that's another webinar or at one of the workshops. And so keeping that in mind, kind of while filling out this poll, we'd love to hear some more feedback, whether it's in the poll or you can reach out to me directly and I can share it with the broader steering committee. Here's just a few more short form interest that others were interested in, maybe an early career talk session, poster session at the next workshop, or a career fair style type mixer at the next workshop, partnering with MTS. And then also in regards to the training, making sure that what we're doing isn't double dipping on what the training sub-focus group is doing, and so we can advertise opportunities. But then also there was interest in common standard helpful practices that other groups have implemented, so as to not reinvent the wheel. That's basically what I've got in terms of those slides. I wanted to keep them short and sweet. I don't know if we want to think that might be it for the poll. And I could probably pass it back to Georgia now.
Amazing, thank you. So I first, again, want to thank the panel and also yourself, Joe. I really appreciate you stepping in and moderating this, and the panelists as well from all different time zones, including the UK, for jumping on and sort of taking time out of your schedules and sharing your experiences. Cassie, can we get the slides back up if possible? I have a few last minute UG2 business items just to wrap up. But my main one really is just to reiterate that UG2 is a group for all of you as part of this community. So we really want to make sure that it's useful and functional for the needs that you have. And a big part of that is it's a collaboration effort. So everyone's been sharing emails, which is fantastic. And I think my biggest advice to everybody is reach out to people. Reach out to me. I can connect you with people that I think can best answer questions or help with networking. Reach out to some of the industry folks, Shea and Cordie, and I think somebody else shared their emails, because you never know. And somebody might be able to help you. They might take your resume, they might pass you on, they might share something. So please, make sure that you use the collaboration component of UG2. We have Slack as well, which is a fantastic collaboration tool. And there's separate channels on there that look at the website, the workshop, data questions. There is a job sort of channel. We're hoping to sort of keep revamping Slack as well. The other thing we're doing too is really working on the UG2 website. We are planning to revamp it almost entirely based on some feedback we've had from UG2 members. We are hoping to relaunch in April. But as I said, this is a resource for the UG2 community. So if you have any big needs or desires or comments or things you want to see included in the website as we move forward with that process, please reach out. I really appreciate anyone's insight and recommendations. And as I said, I want this to be functional for everybody who's using it. So please keep your eyes peeled as well as we sort of move towards that relaunch date in April. And again, just to reiterate, we will be opening the workshop registration and call for abstracts as well in April, with some travel funds available for those that do need it. Lastly, we have our next webinar planned for March. It will be focusing on data management. We haven't confirmed the date just yet, but look out for those save the dates that will be coming your way soon. And I guess on the same vein, if anyone has any future webinar topics they really want us to cover, please send them in. There's an email address there. I'll also share my email as well. I really appreciate that as well, because again, I want to make this useful. And then just a shout out for EGO, which is a sort of international counterpart. They've just started a webinar series as well. Their first webinar was in December, and their next, I believe, will be next month. So we're alternating months for the 2 webinar series. So I think that's everything I have. Again, please reach out to everybody. My email inbox is always open. And I just really appreciate everybody's time joining us today for this webinar. So if anyone has any last minute questions, pop them into the chat. Otherwise, we've finished a few minutes early, which is great. I'm sure people have got other meetings to run to, so perfect chance to grab a coffee. But yeah, thank you again, everybody.
Thank you.